Right, here is your video for square root property. The first thing we want to do in this box up top is review the basics of taking a square root of both sides. So starting right here, if I have x squared equals 9, which x squared is a quadratic, that means it has a power of 2. We're starting a new unit today, which is going to be all about solving equations that have quadratics in them. And today's method is square root property. And so if you have something basic like this, x squared equals 9, you begin by taking the square root of both sides. And then what you have after that is x, so the square root cancels the square, leaving you just x, which is the base. And it's going to equal plus or minus that square root of 9 on the right-hand side. And when you simplify square root of 9, you get 3. So we have x equals plus or minus 3, which you can write like that, or you can break it up into two separate equations rather. X equals 3 and x equals negative 3. And the reason why you need a plus and a minus version is if you were to go back to the original equation, x squared equals, if you put positive 3 in for x, it checks out, right? Because positive 3 squared does equal positive 9. But if you put the negative 3 in for the squared, it still checks out because negative 3 squared is negative 3 times itself. So negative 3 times negative 3 still equals positive 9. So when you take the square root of a quadratic, you need both the positive version of the answer and the negative version of the answer. But in that first example, x squared equals 9, 9 is a perfect root, a perfect square. For the second example, we start out the exact same, but 7 is not a perfect square. So what that's going to mean is we still have x on the left. We still have plus or minus the square root of 7 on the right, but it can't simplify. So we're just going to leave it like that. And again, you could break it up into the positive version of radical 7 and the negative version of radical 7. I'm good with either way of writing it, just as long as you understand, even when it's written in this form, that even though it looks like one answer, it's really two. So we're going to level this up a little bit and we're going to take that x squared, we're going to multiply it by something and add or subtract something to it. So we've got two different versions we're going to work on. The left side version on our page is ax squared equals k, where a and k just represent constants. So here's our first example that we're going to do. X squared minus 50 equals 0. Our very first step right here is to isolate the quadratic term. The quadratic term is the variable with the 2 on it. There's my quadratic term. Isolating it means getting it all by itself, but right now it has the minus 50 on it. So what I'm going to do is add 50 to both sides. And that gives me x squared equals 50. Step 2 is to use the square root property on both sides. That's what we were talking about up in this box up here. The square root property says we will square root both sides, and that leaves me just x on the left and positive and negative versions of the square root of 50 on the right. And then step 3 is to simplify the radical. So I'm going to expand 50 into 2 times 25 because 25 is a perfect square. The square root of 25 is 5. So that comes outside your radical. And I have positive, negative versions of 5 square roots of 2. And I want you to practice that on your own with this next problem. Y squared minus 27 equals 0. Please pause the video and work that problem by yourself now, and then come back and watch the video to check your work. Okay, you should have started by adding 27 to both sides. That gives me y squared equals 27. Here's where we apply the square root property. Y equals positive and negative versions of the principal root, 20 squared root of 27. Now we simplify the radical. I'm going to factor 27 into 9 times 3 because 9 is a perfect square. The square root of 9 is 3, so I bring out 3. And my final answer is plus or minus 3 radical 3. Let's look at this one. This one's a little bit different. 3z squared equals 108. Now this is in the ax squared equals k form from up here. And we want to get the quadratic term by itself. So this is the quadratic term. Right now it's being multiplied by 3. So I start by just dividing that 3 off. So z squared equals 36. Now we apply the square root property. So square root of both sides. Z equals positive and negative versions of square root of 36. Well, that's a perfect square. So my final answer is just positive and negative 6. So I've got positive 6 and negative 6 are both solutions. Now on the PDF version of your notes, it has x squared plus 72 equals 0. But for today's lesson, I need you to change that to a minus. So pause the video and work this problem. Okay, you might have noticed this was just like the first example. We start by adding 72 to both sides. That gives me x squared equals 72. Apply the square root property. X equals plus or minus square root of 72. I'm going to factor 72 into 2 times 36 because 36 is a perfect square. The square root of that is 6, so I bring that outside the radical. And my final answer, plus or minus 6 radical 2. And now we're going to level this up a little bit by attaching the plus or minus number to the x, not outside the x squared term, but inside the x squared term. Because I had in this first example, you know, in the example over here, I had a minus 50, but it was outside the x squared term. Now we're going to look at what happens when you add or subtract something inside the x squared term. So you have something being added or subtracted inside parentheses with the squared on the outside. So here's the first example we're going to look at for that. 4 times y minus 7, parentheses squared or quantity squared, equals 48. So we start by dividing by whatever you're multiplying on the outside, which is the 4. So now I have y minus 7 squared equals 12. So that's step 1. Step 2 says use square root property on the binomial. So this word binomial, by meaning 2, the 2-term binomial that we're talking about is this right here inside the parentheses, the y minus 7. The y is one term and the negative 7 is the second term. So when I say use the square root property on the binomial, I'm talking about that I highlighted. So square root property says we square root both sides. And then the square root cancels out the squared, leaving me just the y minus 7. But still on the right-hand side, I'm still going with that plus or minus version of the radical. Step 3 is to simplify the radical. So I'm going to factor it into 4 times 3 because 4 is a perfect square. And that comes out as a 2. So y minus 7 equals plus or minus 2 rad 3 Now I'm not done yet because y isn't by itself. It's with a -7. So I add that 7 to both sides. But you can't combine it right here with the 2 radical 3 because they're not like terms. If the 7 also had a radical 3, then I could do more math. But since it doesn't, I just stop here. My answer is, you can write it 7 plus or minus 2 radical 3. You can write it plus or minus 2 radical 3 plus 7. You could break it up into 1 plus version, 1 minus version. There's options. I usually write it like this, though. And then I want you, after you write this next problem down, I want you to pause the video and try it by yourself. 2 times parentheses b plus 2 parentheses squared equals 80. Go ahead and pause and try that. Okay, I hope you started by dividing by 2, which gives you b plus 2 squared equals 40. And then you do square root property, which means square root both sides. On the left, that leaves you just b plus 2. On the right, plus or minus radical 40. 40 has a perfect square in it of 4. So when I simplify that radical, I'm going to use 4 times 10. The square root of 4 simplifies as 2. So now I've got b plus 2 equals plus or minus 2 radical 10. And then the last thing I need to do is get the b by itself. So I subtract that 2. Right now it's a plus 2. I need to move it over by subtracting. And that minus 2 cannot combine with that radical on the right-hand side. They're not like terms. So my answer is just that negative 2 plus or minus the 2 radical 2. And then one last example. It has a few more moving parts than the other ones. So this first step is still to isolate the radical term. That's this piece right here, this binomial. But it has a times 2 and a plus 3. And just like regular equations, like if it wasn't the x minus 2 squared, like if I just had this regular equation and I was solving for x, I would take care of the plus 3 first, and then I would do the division by 2. The same idea works here with the binomial that I highlighted. I'm still going to undo the plus 3 first, so I subtract 3 to both sides, leaving me 2 times x minus 2 squared equals 54. Then divide by 2. And then I have this, x minus 2 squared equals 27. That's my binomial. And I apply the square root property to both sides, leaving me x minus 2 equals plus or minus square root of 27. I'm going to factor the 27 as 9 times 3, since 9 is a perfect square. Square root of 9 comes out as 3. X minus 2 equals plus or minus 3 rad 3. Add their 2 to both sides. And these do not combine because that 2 that I added does not have a radical 3. So my final answer is 2 plus or minus 3 rad 3.